All right. So the next unit is on something called regression analysis. All right. So basically, for this unit, what's happening is we're going to be taking some data and basically kind of estimate a function that models that data. All right. So the first lesson here is we're going to be finding the line of best fit. All right. So basically, we're going to be given some data, and we want to come up with like an equation that kind of estimates the relationship between the two numbers. All right. All right. So first off here, the general form of the linear regression model is, and this is y1 is approximately ax1 plus b. All right. So this is, this probably looks familiar. It's the equation of a line, all right, which makes sense because we're trying to find a line of best fit. All right, so let's jump into the first example here. All right, so the 1 hour record is the farthest distance traveled by a bicycle in 1 hour. All right, so the following table shows the world record distances and the dates they were completed. All right, so here we got some data. So we got the years and the world record distances. All right, so first one here is we want to determine the equation of the linear regression function that models the data. All right, so to do this, what we're going to be using is Desmos. All right, so it's a graphing calculator app. Hopefully you've already downloaded it onto your phones, or if you don't wish to, they also have a website. So I'm just going to open up the website and go straight to the graphing calculator. All right, and basically, yeah, this will be an introduction basically of how to use Desmos to come up with these equations. All right, so I'm just going to perhaps try to squeeze both of these onto the same screen. All right, so okay, so the first thing here is once you get to this graphing calculator, let's see if I can spell this way. Okay, so this screen will pop up. So first thing we want to do is we want to input this information, this table, right, into Desmos. So the way you do that, you hit this little plus sign here, and it'll say add, and you're going to go to table. All right. So what you notice is that there's an X1 and a Y1. So down the X column here, I'm just going to place the years, right? So I'm just going to type those in, 1996, and so on. (2009). All right, so down this column here, I just entered the years, and then in the Y column, I'm going to add in the distances. All right. All right, cool. So here's the table. Now, let me just maximize the screen here. All right, so obviously none of these points are showing up here because my grid's too small. So just looking at the years here, I'm just going to go to this little graph settings sign and just adjust my x-axis, y-axis. All right, so along the x here, you can see it goes from 1996 to 2009. So, yeah, so perhaps here I'll just make the minimum here 1995. And the maximum 2010. All right. And same with the Y values. All right, so it goes from 78 to 90. So perhaps here, the minimum Y value here, I'll just set it to 70. And then this one to, let's go to 100 or 110. All right. All right, so now what I've done here is just adjusted the screen. And what you'll notice here is that we do now have the points here. Right? So let's just see how this looks. Yeah. All right. So you can see that these points 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So we have the 9 points that have been plotted, and you can see it's kind of like it almost looks like a line, right? Linear relationships, not perfect, not exact, but so this is what they call a scatter plot, where you plot the points of the data. All right. So Okay, so first step here, we want to determine the equation of the linear regression function that models the data. All right, so what you're going to do is you're going to click to the next line here. So leave the table there. And in here, what we're going to do, the syntax, or the type, what you're going to type in here is you're going to hit Y. And then so it's called the calculator. Okay, so Y. And then I want a subscript. So I have to hit this ABC subscript 1. Okay. And then go back to here. And next I want to find this, click on the squiggly line because it's an approximating it. So this here. Hold on. Actually, I have to hit, sorry, right arrow. Yeah, so make sure, yeah, you hit the right arrow after you hit the 1. Squiggly here, so it's the squiggly lines up top. And here I got A, X, and again, subscript 1, right arrow, plus B. Okay, so just explain exactly what this is, what we just typed in here. So you do need the Y1 and the X1 because that's what refers back to this data. All right, so if you just have X and Y, it's not going to work. All right, so you need Y1 and X1. All right, so just be aware of that. And what this table here gives us is, I'll explain what this is here. As I open this up, down. All right, so what you notice here is it's drawn in this line. Okay, so this is a line of this is what they call the line of best fit. Now, what you'll notice is it doesn't go through all the points perfectly, which is expected because these points are not going to line up on a perfect line most of the time. All right, so it basically finds a line that fits the data the most accurately. Now I'm going to explain what these statistics are. We're just kind of a explanation. Okay, so R squared is called your correlation coefficient. All right. To be honest, you're not going to be tested on this. I'm just going to explain what this is. But yeah, so anyways, if the higher this number is, the more accurate it is, or the more closely the data is clumped together. So this has an R squared correlation coefficient of 96%, which means it's 90% accurate. In other words, all right. So the biggest number here you can get is obviously just 1, right? 1.0, and that's where it's the line would just perfectly go through all the points, all right? But 96% is not bad either, all right? So so this is pretty accurate linear relationship. Now, what you notice here down here, it says parameters. So for this line, the A parameter, or the number for A, would be 0.85848. All right, so that number would be here. So in other words, if you look here, that would be your slope of this line. And the B here is negative 1635.73. All right, so the equation of this line here, therefore, is Y equals this number here, 0.85848x minus 1635.73. All right, so so that's the equation line. So if I was to type this in, if I wanted to graph it, Y equals 0.8 x minus 1635.73. All right, so you'll notice that it is that one. Okay, so let's see here. Yeah, so if I was to eliminate this red line, which is not even showing up there, this line here would be the line. All right, so this is the equation of the line of best fit, or in other words, regression model. So I'm just going to copy, paste it here. All right, so this would be this is the equation of this of the line of best fit, or in other words, the linear regression function that models the data. All right, so yeah, this is your slope, and that's your y-intercept. All right, so with this line, what we can do is we can kind of even find values that are not on the table as an estimate. All right, so next part here says interpolate a possible world record distance for the year 2006. All right, so you notice that 2006 is not one of the years listed in the data. However, it would fall in. It's probably going to be between 84 and 86, right? 84.22 and 86.77. Now, the way to actually find it, the actual value, is if I go back to Desmos here. What I want to do here is find the value for 2006. All right, so what I'm going to do here is I'm just going to punch x equals 2006. And what you'll notice is you're at 2006, it draws a vertical line. And this vertical line is going to hit this line of best fit, or this regression model right there. So if my x value is 2006, the regression line says that the y value would be 86.381. Okay, so this is what they call interpolating. Is when you are kind of basically what you're going to be doing is you're going to be estimating a value that's not given in the table just based on the regression line. Right? So 86.381. Okay, would be the estimate for 2006. All right, if this is the model. All right, now the next one. So what it means by interpolating actually is it's when you take an estimate within the data. Right? So notice the data goes from 96 to 2009. All right, so since 2006 is in between those years, it's called interpolating because you're estimating within the data. Right? Whereas in the next example here, we're going to use the linear regression function to extrapolate the possible record distance for the year 2016. All right, so if I was to go back to this linear regression model, it goes up to 2009. All right, so we want to estimate 2016. So if this trend continued, right, we want to have an estimate for 2016. So so in that case, to answer that question, I'm just going to change this to 2016. I'm also going to have to change the window settings here, right? So, oops. Oh, I got to type them back in. There. Rather than just changing one x value. So let's try that again. So this would be, let's start at 1996. So let's start at 1990. My x. And the maximum value, since I'm looking at 2016, so I'm going to go 2020 as my max value. And then on the y-axis, again, the minimum was 78. So let's go with 70. And then for my maximum y value, let's go with, all right. So, all right, so now, you can see that this would be extrapolating because our last data point over here was at 2009. All right, but we want to estimate 2016. All right, so for 2016 again, I just said x is equal to 2016. It draws a vertical line at 2016, and if I click here, let's see that this would be the estimate. All right, so 94.966. All right, so that would be your extrapolated value. So 94.966. I guess that's so nice. 966. All right. Yeah, so this would be the value you would get when you extrapolate the data. All right. All right. Now the last question here: when would you expect the world record distance to reach 100 kilometers? All right. So let's go back to the graph here. All right. So right here is 94.96. So 100 kilometers is up here, this line. So looks like we're going to have to adjust the windows again. So let's do that. Let's extend this to just to be safe. All right. So so even though it looks like the line has changed, I'm just changing the window settings. So the line still remains the same. It's just, it looks like it's a higher slope because I changed the x value. That makes sense. All right. So now what I'm going to do here is that I want to figure out when it hits 100. So instead of x equals a value, it's going to be y equals 100. Okay, so this time it's going to draw a horizontal line at 100. And then if you click here, you got 2021.864. All right. So the year would be, I guess, it's later on in 2021. So the answer to this one here would be 2021, which is this year. What do you know? So 2021 would be the answer there. All right. Cool. All right. So this is just an introduction here to the how to use Desmos, all right, to figure out these lines of best fit. All right. And what we're going to be going on later on in this unit is we'll be doing lines, we'll be doing curves, right? Exponential functions, logarithmic functions, and sinusoidal functions as well. All right. Cool. All right, guys. So that's it.